All right, guys, we are going to continue looking at trig here, but we're going to go back to our regular trig functions, at least mostly, and look at trig equations. And trig equations are pretty similar to inverses in a sense that we're really going to be solving for angles given a ratio. Okay, so I'm going to kind of show you how that works. There's really kind of two main types of problems. One where you're given a range where your answers need to be between, and one where you're not given them. So let's take a look at a few examples here. So we have the equation 2 sine of theta plus root 3 equals 0, and to the right you'll see this 0 to 2 pi. That means our answers should be between 0 and 2 pi. Now this is not inverse sine of theta, so we're not restricted by some range. Okay, so your answers here must lie between 0 and 2 pi. So the first thing we would want to do, right, is isolate our trig expression. So you would subtract root 3 and divide by 2, and we would get sine of theta equals negative root 3 over 2, right? So basically now in our heads, or we write down, we want to say, all right, where would sine of theta be equal to negative root 3 over 2 between 0 and 2 pi? Basically in the 4 quadrants, right? So if sine's negative, I know I need to be looking in quadrants 2 and quadrants 3, and the reference angle should be pi over 3. Right, reference angle is pi over 3. So I'm thinking, all right, what angles in quadrants 2 and 3 have reference angles of pi over 3? That means theta must be 4 pi over 3. Oh, sorry, not 2 and 3, 3 and 4. Sorry, if you were saying, what are you doing, Mr. Bonner? You were correct. Theta should be 4 pi over 3 or 5 pi over 3. Sorry, I misspoke. Quadrants 3 and 4 if sine's negative. Okay, so pretty simple, right? Now, in reality, how many angles would how many sine, or how do I word this? How many angles would return a sine value of negative root 3 over 2? There's really an infinite amount, right? Because we could keep going around the circle. But it restricted us here only between 0 and 2 pi. So hence 4 pi over 3 and 5 pi over 3. Okay, but now let's take a look at problem 2, where it says tan of theta equals root 3 over 3. Well, the first thing I'd want to do is isolate tangent, which is already isolated. All right, so if tangent's positive, I know I need to be in quadrants 1 or 3. I got it right this time. And my reference angle would be pi over 6, right? I'm just using my triangles now, which means theta would be equal to pi over 6, okay? Or 7 pi over 6. I'm going to write it over here. That's a bad 7. Let me rewrite that. Or 7 pi over 6. But as we said before, we could keep on going around the circle and get a tangent value of root 3 over 3. So what would you want to add to pi over 6 such that you would get the same value? Well, we've kind of already talked about this, but it's been a while. But if I have, right, a tangent angle here, and I want to get the same angle here in quadrant 3, I would really want to add pi to it. That would also give me an angle in quadrant 3 that would give me a reference angle of pi over 6. So really I would want to be adding pi to it, right? And you would probably surmise that if I add another pi to it, okay, I would also get an angle in quadrant 1 that would return the same value. If I add another pi, I could keep on going forever and ever. So to account for an infinite amount of rotations, we're going to use this number or letter n that represents an integer, right? So pi over 6 plus pi n just represents the number of times you could go around the circle. So if n is 2, or if n is 3, or n is 4, or n is 5, whatever n is, adding that, multiplying that by pi and adding it to pi over 6 would return the same root 3 over 3 ratio. So we use that kind of notation plus pi n to indicate that I can keep going around pi times an n amount of times and still get the same value. For 7 pi over 6, we get the same thing. Add pi n to it, you're still going to get a value of root 3 over 3. Now, one of the interesting things with tangent is that I really don't need this 7 pi over 6. Okay, I really don't need the 7 pi over 6 if I have this plus pi over n. Because if you plug in 1 for n, and you have pi over 6 plus pi times 1, that gives you 7 pi over 6. So we've kind of already accounted for it. Now, if you were to put both of these, I probably wouldn't take off, but you'll probably see in my solutions I won't include that because it would just be duplicative. Okay, so just pi over 6 plus pi n in that case. Let's take a look at number 3. 3 is a little bit interesting as well. We're going to do 3 and then one more, and I think you guys should then be all set for kind of all the different things you might see. So we have 4 cosecant of x plus 6 equals 2. Like always, we're going to try to isolate. So we're going to subtract 6 first. So we get 4 cosecant of x equals negative 4, or cosecant of x equals negative 1. I'm much more comfortable with sine than with cosecant, so I'm just going to change it to sine and take the reciprocal of negative 1, which conveniently is also negative 1. So where is sine equal to negative 1? Well, x would have to be equal to 3 pi over 2. Okay, but when we think about sine, cosine, tangent, or sine, cosine, cosecant, and secant, right? If I'm down here at 3 pi over 2, and I have a value of negative 1, and I'm at 3 pi over 2, what would I want to add to 3 pi over 2 to get negative 1 again? Well, the only way I'm going to get negative 1 again is if I add, or I do one full loop around the circle, I add 2 pi to it. So instead of adding pi in this case like we did with tangent, because tangent you only need to add pi to get the same value, with sine or cosine, etc., we're going to actually need to add 2 pi. So I'm going to say plus 2 pi n, and that will account for any amount of rotations around the circle. And again, we can keep rotating around the circle and get the same value. That again, that's what that 2 pi n represents. Right, and if you don't believe me, just test it. Try plugging in an integer for n, like negative 1 or 3 or 2, and solve that. And add 3 pi over 2 to it and see if you take sine of that angle, you get negative 1. And if you've done it correctly, you should. Okay, so on these problems like 2 and 3, right, where it's not given a specific range your answers should be in, you should be saying plus pi n, or plus if you're doing tangent and cotangent, or plus 2 pi n if you're doing any of the other 4. Okay. Be careful. Sometimes with sine and cosine, you might have 2 different answers within 0 to 2 pi. Let's maybe take a look. Where's there one? Yeah, actually, let's do 4, because 4 is going to encompass a couple different things for us. So let's do 4, and then we'll call it a day in terms of the video here. So we have cosine of 2x equals 1/2. Interesting. Cosine of 2x. It might be easier to temporarily take 2x and just say, all right, well, I do know that cosine of theta, if I let's let 2x equal theta, that's a lot easier for me to solve. So where's cosine of theta equal to 1/2? Well, that would be, if we're using your triangles, pi over 3 and 5 pi over 3. That accounts for the 2 quadrants. So I would always start solving these by just giving the angles between 0 and 2 pi, because that will account for the 2 quadrants. Which means my 2 values, if I account for an infinite amount of rotations, would be pi over 3 plus 2 pi n, okay, and 5 pi over 3 plus 2 pi n. Right? That would account for rotating around the circle however many times you want at our quadrant 1 angle and our quadrant 4 angle. That would cover all values of theta. But notice we're not solving for theta here, we're solving for x. So let's go back and remember that we didn't actually have theta in the original problem, we substituted in. So we're going to have to substitute that 2x back in here. So we have 2x equals pi over 3 plus 2 pi n. And we also have 2x equals 5 pi over 3 plus 2 pi n. And again, we're solving an equation here. We're solving for x. That's our variable in this case. So we need to divide both sides by 2, meaning we have to divide everything on the right side by 2, which gives us x equals pi over 6 plus pi n, and also 5 pi over 6 plus pi n. Okay, so notice what we did. We started by substituting in whatever is inside that parentheses, okay, and just substitute it in theta, solved for theta, and then substituted back in again for, or substituted out theta for what we originally substituted in. So it doesn't matter what is on the inside of the parentheses. I would always remove that and replace it with theta, and then at the end, substitute that back in and solve for that variable. So you'll notice we do have plus pi n here, and you might have said a minute ago, Mr. Bunner, I thought that was only for tangent and cotangent, and sine and cosine are always plus 2 pi n. That is true unless we have something on the inside. Okay, and if we have something on the inside, that may change. The good news is if you just follow the algebra, right? How did we get that pi n? We were dividing 2 pi n by 2. So stick with the algebra to kind of lead you to what the ultimate pi n, or whatever that ultimate answer may be. But if you do that theta substitution, you will always be adding 2 pi n, and then when you substitute back out, then let that kind of guide you as to what the final answer should be. Okay, so the rest of these are pretty similar. If we look at number 5, it's pi over, or theta over 2. Again, I might substitute out theta over 2 and substitute in maybe x or something different. Maybe not. I wouldn't maybe substitute in theta. That might get too confusing. But substitute in another variable. Same thing for 6. Substitute that whole thing out. Maybe put in x for tangent, or excuse me, in for 2 theta plus pi over 3. Same thing for 7, 8. 9's a little bit more straightforward. Careful on number 10 when you take the square root. When you take the square root, you have to remember you have a plus answer and a minus answer. So you're going to get a bunch of answers on number 10. 11, be careful with. Number 12 gives you a specific range you have to be in. So be careful on that. Okay, you have a specific range. And then number 13, you can skip. Okay, that involves a calculator. I don't want to get into calculator stuff. So your homework is to finish up the ones we haven't done, which I believe is through 12, 5 through 12. All right, so homework is 5 through 12. Finish the worksheet. Okay, skip number 13.